Hello everyone, I am Levlesh. In this video, I will show you a quick demo of the DLQ dashboard that I have created. You can see that I have a couple of SQS queues in my AWS console. They are all FIFO queues, as this code will not work with standard queues. The code of this DLQ dashboard is split into two repositories. The front end written in React.js and the back end written in MuleSoft. I've tried my best to write a good documentation for both. You can go through their respective README files for detailed information. Let's start with the Mule backend code. After importing the project in the Anypoint Studio, you'll need to set some VM arguments to override SQS connector properties, as you can see here. The AWS IAM role ARN, IAM uses access key and secret key, AWS region and mule.env. If you need help in setting up the IAM role and user, check the README file of this backend's code repository. Once done, you can start the backend. This Mule API is using multiple listeners instead of an API kit router. Hence, anyone can import and run this code without worrying about dependencies. As you can see, the code is now deployed. All listeners have started successfully. I have included sample API requests in the Hopscotch collection folder of the repository. You can import the JSON file into your Hopscotch client and test the various endpoints of the Mule API. Let's start the front end now. You must have Node.js installed on your system. After cloning the repository, open a terminal in the project directory and run npm install command once. Afterwards, every time you want to start the React app, just run npm start command. You will see that a browser window will open where the React app renders. This is the home page of the DLQ dashboard. On the top, you see the navigation bar. It features title and homepage link on the left-hand side, and current time on the right-hand side. The homepage features two charts. First is the approximate message count chart. It is clickable and takes you to the queue page of the DLQ dashboard. It represents approximate number of messages in each queue using a donut chart. You can click on the legend to show or hide any queue. Second is the message retry count chart. This one is not clickable. It represents the sum total of the retry count attribute of the first 10 messages from every queue. As you click on any portion of the first chart, you will be taken to the corresponding queue page. This page features 4 blocks. First block shows queue name and its approximate message count. Second and third blocks are the donut charts. These charts are plotted using the first 10 messages in the queue. The AWS SQS REST API has a maximum cap of 10 messages for read operations, which explains why. The first chart represents the number of messages where the retriable attribute is true or false. The second chart represents the number of messages for every unique value of the error code attribute. The fourth block of this page displays the body and attributes of the queue's first 10 messages in a table. The message body can be viewed using the View button and copied using the Copy button. At the bottom, the fourth block features Delete, Purge and Export operation buttons along with a Refresh button. The delete and export buttons work in conjunction with the checkboxes. To prevent accidental clicks, the operation buttons will ask for confirmation before performing any action. Let's start with the delete operation. Note that the current queue's message count is 12. We'll select any 3 messages and click on the delete button. It asks for a final confirmation. As we confirm, it makes call to the backend API, which performs the delete operation on the selected messages. After receiving a response, the page refreshes, and we can see the reduced message count on the first block. The change reflects on the rest of the blocks too. Now, let's take a look at the export operation. We'll go back to the home screen. Let's transfer messages from main DLQ to Phoenix DLQ. Current message count of both main DLQ and Phoenix DLQ is 6. We'll go to the queue page of main DLQ. We cannot use the message ID as a reference to verify the transfer, because AWS changes it every time a message enters a queue. So, we pick this last message and note that its order ID is 46001. We'll verify it in the destination queue shortly. So we select it and click Export. Then we choose the destination queue, which is the Phoenix DLQ, and confirm export. The React app then makes call to the backend API, and after receiving a response, the page refreshes. We can see that our chosen message is no longer here, and the current message count is reduced by 1. We'll go back to the home page and open Phoenix DLQ's queue page. And you can see, as per FIFO method, the transferred message comes at the last position. Depending on your queue's message visibility timeout, the approximate message count may be wrong. This occurs because some messages might be in flight. Use the refresh page button to fix this. Now, let's try the purge operation on the Ghost DLQ. We'll go to its queue page and click the purge button. The page will ask for a confirmation, and as we confirm, the backend API is called. The page refreshes after receiving a response, and we can see that the queue is now empty. There is a reason why the React app took 5 seconds to load an empty queue. Let's open the property file of backend code. Here we have set the maximum polling duration to 5 seconds. This means that the read operation will take maximum 5 seconds to read messages from a queue. Since the queue is empty, the SQS REST API exhausts the maximum polling duration before returning a response. This behavior is evident on the home page too, as you can see that the Ghost DLQ takes 5 seconds to appear in the second chart. I've logged several variables and states as they change throughout the React app code. To check them, open the developer tools in your browser by pressing the F12 key, and then go to the console tab. That's all for this video. Thank you for watching. I'll see you in the next one. Peace out.